So last time we talked about product rule, which is taking the derivative of the product of two functions. Now let's talk about quotient rule, which is taking the derivative of the quotient of two functions. Let's say I have two functions, f of x on top and g of x on bottom. I'm just going to start off with the definition. This is the way that the rule works, that the derivative of f of x divided by g of x is equal to g of x, the bottom function, times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. If I wanted to rewrite that using prime notation, it would be exactly the same thing. The bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. One thing that I want to point out is that order matters for this rule. Unlike product rule, where we had addition and so we could flip-flop which one went first and which one went second, it's very important that this would be different if I had an f of x on bottom and a g of x on top, because this first term has bottom times the derivative of the top has a positive sign in front of it, whereas the top times the derivative of the bottom has a negative sign in front of it. Why does this rule work? We actually aren't going to be able to prove this until we have a proof of chain rule. So we're going to hold off on proving why this is the case. And instead, I'm just going to demonstrate that it works using an example. So let's look. Our first example is going to be taking the derivative of 2x plus 1 divided by x cubed. Now, in this case, that means that our top function is our f of x function, and our bottom function is our g of x function. Let's put our rule side by side so we can follow along really easily. So for our rule, we start with g of x. This is our bottom function. So I'm going to take my bottom function, which is x cubed, and I'm going to multiply it by the derivative of the top function. In this case, my top function is another linear function, and it has a slope of 2, so I know that my derivative is 2. And then I subtract off what is f of x, that's our top function. So our top function in this case is 2x plus 1 times the derivative of the bottom function. And the derivative of the bottom function by power rule is going to be 3x squared. And all of this is divided by my x cubed function that's going to be squared. So it's x cubed squared. Typically, we can just stop here, that there's no need to simplify. In fact, trying to simplify using quotient rules, sometimes we get things that are much messier than what we started with. But for the sake of this example, I'm going to simplify this a little bit. So this becomes 2x cubed, and the subtraction distributes, and I end up with 2x times 3x squared gives me minus 6x cubed minus 3x squared, all divided by x to the 6th. This is x cubed squared, means it's x cubed times x cubed. So altogether I'm going to have 6 x's on the bottom. Now let's do a little bit of canceling, because there are some terms that can cancel out. I can think of each of these terms individually. 2x cubed divided by x to the 6th, 3 of these x's will cancel out, and I'm left with 2 divided by x cubed. And then, oh, I guess I could have combined these terms. It's okay. And then this becomes 6 divided by x cubed. And then this last term, only 2 of the x's cancel out, so this is 3 divided by x to the 4th. And to finish off, I'm going to combine these two terms, so I end up with negative 4 divided by x cubed. Recall that when I have a denominator with a power, I can rewrite that as negative 4x to the negative 3. The reciprocal, this is 1 over x cubed, can be written this way. And then I can subtract out 3 times x to the negative 4. And I'm done. Now, I'm going to look at this example one more time with the same functions, only this time instead of using quotient rule, I'm going to use product rule to compute it. So let's take a look at this same problem. Recall that I'm trying to find the derivative of 2x plus 1 divided by x cubed. Well, how can I use product rule in this case? I'm going to rewrite the denominator. Instead of writing it as x cubed, I'm going to rewrite this as d dx of the 2x plus 1 function times x to the negative 3. Taking 1 over x cubed can be written as x to the negative 3. And now I'm going to employ product rule. So what's product rule in this case? It's first times the derivative of the second. So again, my first function is 2x plus 1, and the derivative of my second function by power rule, I'm going to put the negative 3 down in front, and this negative exponent becomes even more negative. I subtract from the negative 3 minus 1 becomes negative 4. So that's first times the derivative of the second, plus this is the easy one, second, which is x to the negative 3, times the derivative of the first. This is a linear function, so I end up with 2. Now let's simplify this a little bit. I have a negative 3 times, or 2x times negative 3x to the negative 4. I'm using distributive property. I end up with negative 6x, and what's my power here? I have, essentially this is an x on top, and this is 4 x's on bottom, so they're going to cancel, and I'm left with x to the negative 3. Another way to think about it is that this is x to the 1, and I'm adding the exponents to get x to the negative 3. And then 1 times this term gives me 1 times negative 3x to the negative 4, plus this becomes 2x to the negative 3. And again, I have some terms that can combine, and I see that I have negative 4 x's to the negative 3, and then minus 3 x's to the negative 4, and I'm done. Now, why did I do all this? This is just one example, and we see that when we used quotient rule, we got negative 4x to the negative 3 minus 3x to the negative 4. And then when we did it an alternate way, using product rule, we got the exact same answer. This doesn't verify that this rule is correct, but this is just one piece of evidence to show that unlike product rule that's nice and clean, quotient rule is a little bit messier. And depending upon the problem that you're working on, you can use quotient rule or product rule.